Hi everyone, welcome to another video where we'll discuss things related to Kubernetes and telco. So just to get us acquainted again with this channel, so it's not just all telco, but for now I want to focus on like how to use Kubernetes to build uh, telco networks like 5G or 4G, but it will be mostly 5G. So today is going to be the first part in the series. Uh, in this series, I'll be using SRIOV to deploy a 5G core. And with SRIOV, what I mean is from the server, we'll be creating virtual functions from the physical functions, and then we'll be injecting those virtual functions into the virtual machines. So for to give you a background of what I'll be using, I'm using Proxmox, and I'm using an HP Z840 workstation. And on this workstation, we have I have like four NICs, actually two PCI NICs. Each PCI NIC has two 25 gigs network card, and the two of them, one is Intel and then the other one is Mellanox. So if we do a IP address just to see what I have currently on the system. So here is my Intel. This is my Intel NIC. These two, the ANS4F0 and F1. These are the Intel physical NICs. They are capable of SRIOV, and also this other one is the Mellanox. So currently I've created some virtual functions on the first Intel NIC, and we'll just see how we can also create it if we want to create it on the second NIC. So for you to, just to show you what I have currently on the system. So if it's good to use. I like using, even though we are not binding to DPDK, but this script gives a very good overview of what your NICs are, what the NICs are running on your system, and then what the drivers they are currently using. Now, if we look at this, you can see here, like I said, the ENS3F0, NP0, and the P1, they are the Mellanox. So you can see here, it's showing the Connect X5. And then you have the two Intel NICs also, like I said, the ENS4F0 and ENS4F1. So you see here, so the driver is the i40E. Then you see the model, which is the XXV710. This is capable of up to like 25 gigs. And once you create the virtual NICs, you see that it creates, currently I created like 32 virtual NICs. So you see it starts from 0, but the reason you don't see all here is because I've already injected some of the VFs into the Proxmox Kubernetes worker nodes. So if they are not, and Proxmox uses the VFIO PCI driver to actually, it uses it to inject the virtual NICs into the VM. But we can just do a sample and then try to also inject into the second Intel NICs. So take note that what we have currently, it starts with F0, V0. So by the time we inject, we create VFs into the second NIC, you will see that it will also show up here. So just to make this a bit quick, so let's create 8 virtual functions, and I'll be using the F1 NIC. So if we run this command again, then we'll see that we now have 8 NICs, 8 virtual NICs that have been created. So you see that it starts with F1 V0 up to F1 V7. So 0 to 7 will give you 8 NICs. So that's a brief overview. And one thing that is cool with the SRIOV is that the VFs is that even when you create the VFs, you can actually plumb them into Kubernetes into drivers, right? And even in the VMs, you can do that. So it gives you a lot of flexibility. But when do you use SRIOV? It's all a matter of design, right? So SRIV may not be suitable for some kind of traffic. Mostly, it's more suitable for kind of the north-south traffic, so that you bring traffic into your node. And then if you have traffic within the node, then there is no real advantage you using SRIOV. So you could make use of the default bridge that comes with your hypervisor, or you could create some other bridge yourself using the like Open vSwitch, or you use VPP. So either one of the two, you can. If you use the default Linux bridge, you get a bit of performance, right? But if you truly want some kind of huge performance, you could make use of the OVS DPDK variant of the Open vSwitch, or you could make use of the VPP also, and then you make use of uh, DPDK memory interfaces like MEMIF or the vhost chooser. So either of these two, you can use it to accelerate the traffic switching or the traffic bridging, whichever way you want to refer it, within the same box. So that's a little bit of SRIOV, and then the advantages and where you will use it. So for these, in the second video, we will actually be seeing how we'll do the injection into the 5G core. And for that, we are going to make use of a lot of SRIOV for those interfaces like the N1, N2, N3, N4, and N6, just to show you some the way it's done. So in Proxmox, if you want to inject PCI cards into the VM, you have a sample command that you can use. So if we scroll up, so you see here you have QM. That's the command to set the host. I mean the PCI address. So this is the VM ID, okay, and then you set it that, okay, you want to start the injection from the PCI 0, and then you put the PCI address. This PCI address must match exactly with what you have in your host system. So here, I'm actually injecting like eight virtual functions into one VM. I'm also attaching 8 virtual functions into another VM. And actually, this VM 106 is actually my VM that I've dedicated for the 5G control plane, and the 107 is the VM that I've dedicated for the 5G user plane. So to clarify, I mean, to show that clearly in Proxmox, you see here that I have the 5G control plane here, and then you see the PCI devices. You can see these are the PCI addresses that has been injected into it, and it's the same that is here in the user plane virtual machine. So the Kubernetes cluster I created is a 3 VM Kubernetes cluster. So you see I have a master node or the control plane, just one, and then we have the 2 worker nodes. What I used in creating that is Rancher. So it's not it's not so particular, or you are not. The reason why I don't want to go into the details of setting up your Kubernetes cluster is there are several ways of setting up your Kubernetes cluster, and for me, I think Rancher is a bit easier for me to at a glance. So you see what I'm doing is I have the control plane, and the control plane or the master VM based on the whole naming convention. So you see this is only for the control plane and the etcd. And then I also have the control plane node. This should not be confused with the Kubernetes control plane, but what I mean here is the actual 5G control plane node. So this will host the CNFs like the AMF, NRF, SMF, and all the like. So, and then the other one, the other virtual machine here is for the user plane node, and this will host like the UPF. So we'll see in the second video how the 5G core will be deployed. But this is just to give you how I created the cluster. So if we move into the virtual machines themselves, so you see this is the 5G control plane node. So if we check the IP address, so we see this is the Kubernetes primary interface. We are not that's not what we want to look at. But then if you see from here, you see all the way down, you actually see that we have 8 interfaces which have been injected. These are virtual functions that have been injected into the VM. And to give a very good command to confirm to you that we are actually running the VFs right in the VM, is once you run this command, you see here that it's actually showing you that it's the Ethernet virtual function and the 700 series Intel card. So I'm trying to, this is just like a background before we move into the to the other video, because it will be good for you to have a brief overview. So that's that about injecting the virtual functions NICs into the virtual machines. Now, when you have injected the virtual NICs into the virtual machine, how do you consume it inside Kubernetes, right? So injecting, now one thing I want to tell you is that at this level now, in the VM level, what you are seeing here is exactly what you will see in most cloud platforms, right? So because in the cloud platform, the VFs, like I said, is already created in something like Proxmox, and then they will be injected into the virtual machine. So you don't, and these virtual machines, you can't run SRIOV on them again because they're already virtual functions. So in essence, if you want to consume these NICs in your pods, you can't make use of the SRIOV CNI plugin, because we have another plugin that is that works exactly. That works with SRIOV NICs. What you can do to consume this is to use a combination. Well, I prefer, my preferred mode of consuming these NICs is to use a combination of Multus and then the SRIOV device plugin. Now, let's quickly see the SRIOV device plugin. First of all, we'll see how we are picking up the values, right, from how we are populating the SRIOV device plugin daemon set to select the virtual functions. So you see, we are naming the resource. This is the name of the resource, and then we are saying the vendor is this, and then the type of device, and then the driver. All these values, you can actually see them also in the in the node, or in the virtual machine. So if we scroll up here all the way, we can see that if we use the ls PCI command, here you can see where we are getting those values from. You can see this is 8086, and then this is the device class, and then the driver is this. All these 3 values, you will see that that's what we're actually using here. So you can see the vendor is this, and then the device is this, and then this is the driver. So what you are telling the SRIOV device plugin is, any interface that matches this, then it should populate it in the kubelet, so that we can now consume it. We can now use Multus to inject it into the pod. It's very, very important to get this. These values will definitely change based on the type of NIC, the network card you are using. All right. So now we've gotten the SRIOV device plugin config map. Now let's see from the value of our Kubernetes. So let's see what our kubelet says in terms of the allocatable resource, because once the SRIOV device plugin comes up, it's going to populate a particular field in the nodes to say that on this node, these are the resources that are available, and part of the resources that will be available will be the VMs. I mean, will be the virtual functions. So let's see if I still have this in my, yeah, I think I still have this in my history. So yeah, so if we run this command, what this command is just doing is you are getting each of the Kubernetes node, and then you are exporting it to JSON, and then you are using JQ to get the allocatable resources. So now you see this is the Kubernetes control plane node, because we are not going to be scheduling pods on it, so we are not going to make use of this. So that's why I did not inject virtual function X here. So, but then if you look at the control plane, the 5G control plane node, you can see here that the SRIOV device plugin has injected 8 VFs, right? And the same thing for the user plane node. This is very, very important. This is how you are sure that you can allocate these resources into your pod. So this SRIOV device plugin, once it comes up, it will read the config map, and once it sees those resources, it's going to populate back to the kubelet. Now, the SRIOV device plugin is just a part of it. Now, you could also make use of, instead of using the SRIOV device plugin, you could actually make use of the host device plugin alone. But the problem with that is that you have to create a network attachment definition for each of the virtual functions. So we are not going to use that, but I just want to show you another way to achieve the same goal. So now this is your network attachment definition, which is Multus. And here we are still going to make use of the host device plugin, right? But take note, we are not specifying the actual device or the PCI address of the device. The reason we are doing that is that there is a function that maps Multus with SRIOV device plugin. And where that happens is this. You can see the name of this function here maps to what you have here in the SRIOV device plugin. And the vendor, of course, the number for the vendor is this for Intel. So that's why you are seeing Intel, right? So you are seeing intel.com/Intel SRIOV net device plugin. What this means is that once you are creating the pod and you want a pod to consume, I mean, if you want the pod to make use of one of the VFs, you first of all reference this network attachment definition in your pod template. And after you do that, you have to go the extra mile again. And under the resources section, you still need to say that, okay, how many of these resources do I need? So it could be 1, 2, or 3, whichever one. So the advantage of this is that you see that you are not creating multiple network attachment definition. You're only creating one. And with the help of the SRIOV device plugin, you will be able to, it will create sort of a list of these resources. And once a pod comes up, it will take note, we have 8 per the worker nodes, right? So once one pod comes up, you see that it will just pick it from one of them, then it will remain 7, right? And then if you pick another one, it will remain 6. So that's the advantage of this. And it gives you a bit of then another advantage with this is that if you make use of this using Multus, then you'll be able to like also assign IP address. I'm using static here, but you could make use of whereabout and stuff like that. But that's beyond our discussion today. Now, let's see an example of a pod manifest that makes use of what we've just said. So here we see we are creating pod 1, and then here, look, take note where this is the Multus, where we specify the Multus, and then we are specifying the network attachment definition name. And then since we put it is static, so we are putting this IP there. Now, take note that normally in Multus, this is sufficient when you are doing just Multus alone. But now, since we have Multus and SRIOV device plugin together, we will need to also specify the resources. These resources must also match what you have in the SRIOV device plugin. So essentially what we are saying is we just want one of those NICs, of those virtual functions. And if we see that so we don't have any pod here, so if we do the apply just to create those two pods, and then if we do get pods again, so the pods are getting created. So at the end of the day, what we are trying to do is we should be able to ping both ports from each other, right? So you have 10.1.1.1 and then 10.1.1.2. So let's just check that again. So you see the first port 1 is using this IP and port 2 is using this IP. So also it will take some time because I'm just applying some, we could have used some other network another container image, but I just want to keep it to the Nginx just to see that we should be able to coil these IPs from one another, and then we'll be able to get the results. So let's go into port 1, but let's just pick up port 2's IP address. So if we go into port 1 and we do coil into, so I think port 2 should still be coming up. Let's see. Let's go into port 2. Is up. Let's ping port 1. The ping is working. So let's see the coil from here. Okay, so port 2 is able to, let's go back to port 1. So I think the Nginx process was not up there. So yeah, you see it. So you see that we can actually make use of the SRIOV interface that was injected. So this is the SRIOV interface net 1, and this is the IP. So in the next session, we'll go much deeper to just see how we can now extend this into our 5G core. So just to let you know about what we'll be looking at in the next video. So this is the architecture. So you see that I'm just using SRIOV for most of all the interfaces. So like I said, ideally this may not be the best way to design, but this is just to give you an example of how you can make use of the SRIOV virtual functions for your 5G network. So I hope this video was informative for you, and if you like it, kindly click the subscribe link, the subscribe button, and also share and give us a like. Thank you.